Hey, it's me, Destin. Welcome back to Smarter Every Day. This is at the Kodak Film Factory in Rochester, New York. The fact that we got to film in the plant is amazing. This is how Kodak photography film is made, and this is the third of 3 videos. In the first video, we looked at the backing. How did they make that stuff back there? We learned about films with S-star backing and the incredible engineering involved in taking these plastic pellets and then melting it in a special auger and then extruding it and then stretching it out and cooling it over a continuous process. And we learned about a concept called an accumulator. This is a clever arrangement of pulleys that spread out to collect material inside the production line so that you never have to stop the extrusion from the auger. This allows you to never stop the process from moving, while at the end of the line you can stop a roll and make a cut. In the second video, we took that wide roll that we made, right? And we applied a light sensitive coating to it with, get this, a laminar flow waterfall. I kid you not. It's incredible how this thing works. They're actually applying multiple layers at once with this waterfall, and they make the layers like in these special kettles down in the basement. And oh, by the way, everything is happening in the dark. And after they apply the coating, they have to go dry it over like a mile of conveyance, still happening in the dark. They're hardly touching this stuff because they're moving it with air. In fact, they use these 90s era robots to move stuff around. It is a technological marvel. So at the end of video 2, we have this light sensitive film in these big light proof boxes called caskets, right? So at that point, we have to figure out how to cut it up so that it's small enough to put into a camera. We have to it's called slitting. We have to slit the film, and then we have to put these little holes in it because these little sprocket holes are important for it running through your camera, right? So after we do that, we have to then build this can. We're gonna get to see how they build the can, and then we have to put the film in it, and then after we put the film in that can, we have to put the whole thing in this can, and then we're gonna get to see how they put it in this box. This process is incredible, and I'm very excited to share it with you. Before we start, most important thing to remember, the film we're going to be dealing with today already has that light sensitive coating on it, so we have to keep everything in the dark until that special moment when a shutter is allowed to open and you expose the image. By the way, I'm going to take film photos throughout this process, so you'll get to see the Kodak process filmed on Kodak film. Very cool. Anyway, let's get started. I'm going to introduce you to Patrick. Patrick is a young engineer who's been spending the last few years since he got out of school learning this entire process, and he's going to walk us through every step. Now, this process is amazing, but we're going to start right here at the slitter, and we're going to go meet Tim. Tim is the operator of the slitter, and he can literally do this with his eyes shut.
This is where we slit the film. It comes in from coating in a wide roll form, 54 inches. This is all dark. It comes in to the cover lifter. Cover lifter comes in, takes the cover off.
So that would be the casket, and you're lifting the lid on the casket.
Correct. The lid's up there.
Oh, gotcha.
Once that's off, we go in, check the roll, make sure we got the right roll. We'll hit some buttons. It automatically loads onto the slitter. This will slit 12,000 feet. So one of these large caskets holds 12,000 feet.
Wow.
In this slitter, we usually do the full roll, 12,000 feet.
And there's about 5 feet per 35 millimeter roll. Is that right? Did I get that right?
Yes.
Yeah.
That's right? All right, so this is Patrick. Patrick's an engineer.
Nice to meet you.
Doing all right?
This is the unwind. So we put it on the unwind, thread it up. There'll be a leader in the machine.
Is this PET or is this acetate?
This is S-star.
Okay, S-star. Got it.
Yes. So you've got your 2 banks. You got your even and your odd bank. This is a 35 millimeter slitter only.
So you have tension on one side on the whole sheet, which is right here. This is a whole sheet going.
Everything's got tension.
Everything's got tension?
Yes. You have to
Yeah, these
have
are
tension
pulling
to have control.
tensions. See these spinning?
Yeah, they're spinning right now. Oh,
Yes. Yeah.
wow. Okay. So is this actually moving leader through right now?
No.
Okay.
We're not jogging. We just have tension.
So this is idling here.
Yes, those
Okay.
have clutches underneath those
Directional
coils.
clutches?
Yeah.
Yep.
Oh, that's how you maintain tension.
Yes.
Gotcha. Okay, I'm with you. That's cool. So Tim, you know everything about this machine.
More than anyone else.
Yeah? So is Tim the guy? So
He's the guy.
So are you an engineer? What's your title?
No, I'm just the operator.
I didn't mean to offend you by calling you an engineer. So he's an engineer, so you're basically teaching him.
Yes. Oh, yeah.
Yeah? That's how that works, isn't it? Like every manufacturing job I've ever been in, the operators teach the engineers. That's the way it works. That's awesome.
So you've got, you know, that's the even, and then you got the odd bank over there. So this is basically the odd bank. They're all stuck down, and then you got your salvage edges going to the, you know, those are just waste.
And so you go get the silver out of that somewhere.
Yes, yeah, it gets taken and sent over there. This is obviously, you know, your scrim.
Okay, and that's where they knurled it over on the S-Star line.
Correct.
So since the slitting machine is so big, we can only see it in pieces, this is what we're looking at as a whole. We've got a big roll of film unwinding and being fed into the machine. It goes up and over and down to a series of blades that slit and send half of the film to the odd side and half of the film to the even side to be rolled up. The edges are trimmed off and then sent over to a bin so they can be recycled. So up until this process, you know, after we did the photosensitive coating, everybody's been worried about touching that side. But here, it looks like I've got a roller is it coming in contact here on the other side? So
Yep, yeah, so we touch the emulsion in this building mainly because it's actually dried at this point, right? By the time it gets to us, it's no longer just a wet emulsion, right? It's got some stiffness to it, so we're allowed to actually roll and wind on that side.
So do you have night vision goggles in here?
Yes.
Okay, that's how you have to do it, yeah.
I really don't use them.
Nope.
What? I've been working in the dark for almost 30 years, so it's nothing. So you can actually see fairly decent. I could see him in the dark, but you go over to a K3 slitter where they do that film there, you know, the 135. That, you know, you can't see me from me to you.
So are we doing 35 millimeter right now?
It's 35 millimeter, but it's a different.
Yeah, so this is print film for the movie industry.
Oh, okay.
But the sister slitter, the same
slitter.
Over.
It's the same thing.
Got it. So question here, what is our final product from this room? We've got over here, we've got the big roll of S-Star coming in. We're slitting it. We're making our even and our odd, our odd and our even. What are we sending out of this room? Are we making rolls here?
Yep.
Yes. Once the machine starts, you'll see these carts come in underneath the rolls. So once they come under the rolls, you know, the rolls build, and usually the rolls are like 12,000 feet. Once they're on there, and they go out, they'll go out of the racking, and then they'll go down the hallway.
Oh, am I seeing rails here?
Yes. Yeah, it goes right in. See that
so
rail
we've got
there?
a whole automated system to handle
All the
these
handling
rolls.
system is automated. So it goes from here to the T's.
So you're not past this point in the dark.
No.
When it's running.
No.
Unless there's a problem.
So you want to see it running?
Yeah. Yeah, that's great if you don't mind.
Yeah.
Okay. So now that's unrolling.
Yep. Yeah. So if you look through the window here, you can actually see the web moving.
Okay, so it's actually going now. It's going up that way. It's hard to see, but it's happening. Okay, can I come over here?
Yep. And then so now we're coming up through the web path up above the machine.
Okay.
And that's where we have some tension controls. We've got our web steer here in the middle. So you can see that right here. So this thing will actually move side to side a little bit to keep the web centered.
So it's moving this way laterally.
It actually does it on a pivot.
A pivot. Okay, got it. So it's feeding this way, right?
Yep, so it's coming across. And then it's actually going to be, it's tough to see in here. It's actually going to come down.
So I can see it moving through there, coming down.
And then we will end up through the knife set here. That's where it's actually getting turned. You can maybe see right through this window here, the web actually coming straight down into the knives.
Okay.
And then now once it's through the knives, it's going to go up to the rewinds. Now it's 35 millimeter, right? So now it's coming back up as 35 millimeter through the flanged rollers onto the core. And then we just saw the...
So is it spinning up on each side?
Yes.
Okay, I didn't realize that. So you're filling this side and you're filling that side.
That's because we want to split the web as soon as we can coming through the knives.
So this is it right here, right?
Yeah.
This is the product.
That's 500 feet.
Okay, so we filled 500 feet up, and now you have to...
I got to get that film off. So in order to do that, we put the vac on, do a splice. Now, normally in the dark, we would be sending this out and bringing another full roll in behind this. But since this is a leader, we're going to keep the leader in because I'm going to get rid of that waste. So we're going to do a splice. Again, this is all in the dark.
Wow. That's a vacuum? Is that a vacuum right there?
Yes.
There's
Yeah,
vacuums
vacuum plate.
upper and lower. Or vacuums, yeah.
Okay.
So that's double-sided splice tape. So you'll see when that goes back, it's going to reverse and automatically stick the 500 feet rolls down. It'll be clear in a minute when you see this happen.
Okay, understood. So the splice is running now?
Splice is running now. You can actually go in. When it comes down, you'll see these arms come up. You can hear the tape going through the rollers right there.
Uh-huh. Where's the splice at?
It's right over there.
Just passed down. Now it's going to go through the
Going
knives.
through the knives now.
I see it. And that's why it has white markers on it so you can see it?
The white is the adhesive for the.
I guess it's in the
tape.
dark, so it doesn't matter.
Yes. So that just separated all the everything. You see what I mean now?
Yeah.
All
Okay.
these rolls are stuck down.
Oh, I see.
Go to the next operation.
I see.
If we didn't do that splice, this is still attached to the roll. So how does it get out of the room?
So this is like a perforation. So the splice has the ability to rip easily. Is that true?
It's double-sided.
Okay.
There's adhesive on both sides. So when it reverses, it rips off the one side.
Got it. Okay, I understand now. So basically the splice is preemptively getting double-sided tape ready to go to close out this roll.
Yes.
Is that right?
You're using double-sided tape to close out the roll, yes.
Got it. Okay, cool. That makes
Okay.
sense. Yeah. So you can see the confusion on my face over there.
Yes. I said it. It'll make sense once you see it.
Okay.
All right, so that's the same thing. We just make sure they're all stuck down.
And so can I freewheel this?
Sure.
Okay, so, and I should see it closed out on the, there it is.
Yeah, they all have them.
They
See
all
them
have
all
'em.
right here.
Yep. Okay, got them. So some of the clutches spin more freely than others.
Yes.
Got it. And so now you're going to automatically have this cart move over there.
Yeah.
Okay.
Normally, this cart moves out, and this rack goes all the way over to the other side, and then they go out of this room into the T-perf machine.
Is this how they send back the rolls to you?
Yes. Yeah, there's another room next to us that collects all these.
Got
and
it.
then we get them from that room.
Dude, you're good at this.
I don't know.
That's pretty cool. Yeah, that's pretty legit. So you're about to send these out?
Yep.
And
All
so
right.
it's going to go over? Or?
No, that's where it's stopping because I'm going to take that NG film and throw it out. And
Got
then
it.
put them back on. But like I said, normally when you're in production, those are going out.
And so this machine is all about managing tension.
Yes.
Yeah, tension's very important for your slit width and everything. You lose tension, there's going to be film all over the place.
Wow. Okay. It's a big deal. That's awesome, man. This is great.
All right.
Sweet.
Patrick walked me a few steps away to where they had a huge assembly, the slitting machine blades, and we had a brief discussion about how it works.
So we've got an upper and lower set here in this frame. So we've got the upper knives up here.
Okay, show me a knife. These
Right,
are the
so
knives?
this is a knife blade.
So that's a right angle edge right there.
Yeah. So there is some geometry science we can't go into here,
But it shears right here too.
yes, right. So this is a shear cutter.
So the film runs straight through here.
So we kind of use two different processes in this building. We've got shear straight through slitting, and then this one where we actually wrap around the lower roller.
So it's coming in here and it's going to make contact with this roller, which also has a sharp edge on it.
Correct.
Goes around and goes out another way. And so it's actually making, how many degrees of contact would you say before it gets out?
We'll say about 100, maybe less.
Okay.
That's awesome. Thank you very much.
This episode of Smarter Every Day is sponsored by NordVPN, and you've probably heard of VPNs, virtual private networks, but I want to tell you a story which I think is interesting. My grandfather used to have this little trick. He had an old shirt that he had in his closet, and he would put this old shirt on. It had holes in it. It's kind of like this one. He would put that shirt on before he went to buy a car or something like that because he didn't want the salesman making assumptions about what he could afford based on how well he was dressed. There's a new way to use VPNs that I did not know about that's very similar to the trick my grandfather used to use. You know that websites track your IP address, right? They know where you are in the world and where you're accessing their website from. Now, interestingly, I didn't know this until recently, they will change the price on hotel rooms and on like electronics based on where they think you're from. I think this is interesting. This is a really cool use of a VPN. So instead of saying like surfing the internet from America, let's use NordVPN to connect from, let's just do Colombia. And you'll notice if you go to different websites, you will get different prices based on what they think you can afford. In the US, Microsoft Office is offered for about $100, makes sense, right? In Colombia, it's $77. That is a significant difference. But check this out. Adobe Creative Cloud, $1,000 in the US. In Colombia, it's offered for $198. Say what? What's going on here? I think this is amazing. And if you want to try this, you can get NordVPN by going to nordvpn.com/smarter. That is the best deal you're going to find online. So go check it out. You get a really good discount on a 2-year plan. You also get 4 months for free. So nordvpn.com/smarter. They have thousands of servers in 59 different countries, so you can check out the internet from any of these locations. One thing I've always wondered about is, can you double VPN? Yeah, you can. There's a button right there. One account lets you connect up to 6 devices, so I have it on my phone, get it on a couple different computers. NordVPN is super fast, so you don't have to sacrifice speed for security. Go to nordvpn.com/smarter. Also, if you don't like it, it's a 30-day money-back guarantee. If you try it and you don't like it, they'll give you your money back. I'm grateful to NordVPN for sponsoring this episode because I really like making content like this. So now that we've slit these big rolls of film down to the right width to fit into a camera, it's time to see one of the processes I was most curious about, and that's putting these holes in the sides of the film. Mechanical cameras have these little sprockets that line up with those holes, and it has to be just right. If they get it wrong, then it's not going to feed through the camera correctly, and it's going to be a nightmare. We headed through a labyrinth of halls to see the very special machine that does this, and I met Matt, one of the operators that makes it happen. So right now, this room has lights on, but it's usually dark.
Yes, we work in a dark environment. So again, as you said, here's our booth. This is basically the brains of the operation.
And this is on curtains so you can see the screen.
Yeah, so no light damages the film.
Okay.
It keeps the light contained.
Sounds great. So what are we trying to do in this room?
So this is how the film comes in. It's just one piece of film. What we want is a finished product with the perforation.
Oh, okay, so we're punching holes.
This machine right here, this is the heart.
So this is what lets the camera grab the film.
Exactly. That's where the sprocket will grab the film and drive it through the camera.
Oh, wow. Okay.
So yeah, so this is where we put the holes in and finish the product based on the customer's demand, what size they want, what particular code.
Okay, so you can do different hole sizes and different dimensions.
We have different punches, yes.
Really?
So yes.
So this is where you put the core over here?
So, well, to be honest with you, what happens is this door here would be open. As you said, we're in a dark environment. This door would be open. There's an arm that'll reach into the rack, bring the roll in, and automatically load it.
Okay.
Then this arm comes down. It puts all the computer information that we need to produce this roll.
How does the arm know the computer information?
Well, it downloads from the actual rack.
Okay, got it.
There's a card on the rack.
Got it.
That'll be read, and then once it's sent into the computer, it's going to know that it's a 2,000 foot roll, 4,000 foot roll, or 6,000 foot. Okay. So the customer has different demands. And it's also going to tell it what print to put on there.
This looks very complicated.
The nuts and bolts of it is. It's very complicated. But for an operator's point of view, it's really not that difficult.
Okay.
There's only a couple interactions I actually have with the machine. Everything else is automated.
Can you show me what they are?
Yeah. What I'm going to do, So this is exactly how the roll would have been loaded in under a dark environment. So as an operator, I'm going to take this tape off because we don't want that. So this chops it. And what we want is a rounded edge because we don't want to damage the heart.
Okay.
So
A rounded edge. So it's a very specific.
very specific cut.
A
Yeah.
rounded edge.
Yeah.
Okay, got it.
So we don't want this going through the heart. On the other end.
Okay.
Because there's a chance when it splices through, it'll damage the heart.
So that was a vacuum right there.
yeah.
So
Hold it down.
that's the back side of the film, so you don't scratch it.
Exactly.
So on the roll, where is the photosensitive part? It's on the inside.
This is the emulsion, yes. And this is the support.
Okay,
The outside is the support.
gotcha.
So now I'd pull this knife off, there'd be a balance, I'd throw that out.
Okay.
And it keeps me from overlapping the film. So I butt that up to the knife. I'm going to reset it. Now I take a piece of tape. And you want it in the center of the film. You don't want it being perforated.
Okay.
So now I'm going to take the
You don't want the tape to be perforated because it'll mess up your punch.
It's very cool. It could be. Or tape could get stuck on the heart and cause damage. There's a number of things that could happen.
Gotcha.
So now I'll take the slack out. And I'm going to send the film through.
Where should I be looking right now?
It's, well, all this. You got this arm moving. The film's going to kick through this end. And it's predetermined to make sure that I get the tape off. So this board comes out, the knife will cut the film so that I have all the tape through the machine.
Gotcha.
And then this would be what we call a scratch test end. Every roll that we run will have a scratch test end that I would send to the tube system. That goes to the quality lab, and the inspector will verify that it meets our standards.
Got it. So what? This machine is the scratchiest machine in here.
The scratchiest?
Like you said, you're going to test scratch testing. Is that what you said?
Well, this is to verify there is no scratches.
Got it.
Yeah, because obviously the customer wants perfect film, and that's our goal.
Got it.
So this verifies that every single roll we run is physically checked.
Perfect.
So there's no defect.
Gotcha.
And then we manually wrap it around the core.
I'm gonna get right here.
Okay, that's fine. So we got tension on the roll.
Oh, okay. You didn't tape it or anything. You just
No.
let the tension do the work.
Exactly. It'll
Okay.
wrap around itself. Then I'll hit the builder arm. And now we got the door open for demonstration purposes.
So stay
Normally
back.
this door would close.
Got it.
So now I'm going to start the machine.
All right. So where should I be looking?
So this is where it's going to wind up. It's going to unwind from the back end, and it's going to wind up here.
Okay. Sounds good. Got it. That's really fast, Matt.
It runs up to 3,000 feet a minute.
That's really fast.
Yeah, we used to run 100 feet a minute on the old style machines.
So this really increased productivity.
Yeah, greatly. We've been doing it this way for about 20 years, 25 years.
Did you run it on the 100 feet per minute system?
I still do. Some
Really?
products we still have to run that way.
Can you show me where the holes go?
For the, oh, you mean the perforation?
Where is it cutting the hole? Where is it punching the hole?
This right here that's spinning. So this is the actual punch drum. This is the die drum.
Okay.
So as it rotates, it's pushing the perforation.
Oh, I see it right there.
Yeah.
So those are the little posts.
Punching the holes in the film right here.
Yeah.
And the film that's ejected goes into the heart and it gets vacuumed out through these exhaust tubes.
So if I had a high-speed camera, I would see little holes of film going that way.
Yeah, if this was clear, yeah, you see the vacuum taking them out.
Is there a bucket of those holes somewhere?
Right around the wall, I can show you after we're done.
Okay.
There's a big bin.
Sounds good. So can you run this? So we're done. We
Yeah.
slurp like a spaghetti noodle. We slurp the end of the film up, right?
Exactly.
Okay. So that roll is done. So at this point, how do you take the core off?
Now, if this was actual production, I wouldn't. What would happen is, this arm right here, you see there's a core there?
Yeah.
This arm comes down, it takes the empty core, comes back to the retracted position. While that's going on, the manipulator arm is bringing in my next full roll of film.
That's awesome.
So yeah, I don't touch anything on this end.
Gotcha.
It's all automatic.
So what on this machine do you worry about? Is there something that typically messes up?
Not usually.
That's impressive.
You might get an unusual occurrence once in a great while, but they're very reliable.
That's impressive.
So
How many of these do you guys have?
we have these 2 here, and then we have 7 on the other side.
7 on the other side?
Yeah, we used to have 28, but because film isn't quite as popular as it used to be.
It's picking back up.
No, I love it. I love it. So,
Do you like your job?
oh, I love it.
Yeah.
I started 26 years ago, and obviously going through all the changes we've gone through, I'm really surprised to still be here.
Yeah.
A lot of us never anticipated that with all the bad news, you know.
Are you seeing production go up?
Yeah, it seems to be headed that way, because actually been working some overtime. We hear about all the directors out in Hollywood that still love film.
I still shoot film.
Yeah, no, friends of mine, same thing. When you go upstairs, they still shoot 120, and I'm a big music fan. So I still got record albums. They're coming back.
Oh yeah, isn't it awesome?
So yeah, it's really
legit.
cool.
I love it.
Because I told guys, just because it's new doesn't mean it's improved.
I hear you. Can you show me the holes that come out of the film?
Yeah, I'll show you right here. So what happens is, when we were running this whole bank of 7, all the perfs get sucked out through the vacuum. And we have these 2 big hoppers right here.
Okay.
And this is where they get dispensed. So right here.
Oh wow.
Yeah.
Dude.
So that's how much film we've run.
That's amazing.
All those little perforations.
And that's silver. There's silver in that.
Exactly. So we recycle it to recover the silver.
So once it comes out here, it's in the light. So this is you just recycle the whole thing. Can I get a picture with you in there, Matt?
Oh, sure.
So I'm sure he told you, right, that middle bit that's actually making the perforations, we call that the heart, right?
No, he didn't tell me that.
Okay, so we
So-
nicknamed that the heart.
I will say that the operator, Matt, he seemed to not have a big concern about that, which tells me that the engineers are doing their job right.
Yeah, there's a lot of technology going into developing that system, right? 3,000 feet a minute is not slow. When you're perforating at those speeds, there's a lot of extra things that you have to start thinking about.
Okay.
Right? I mean, when you're up at 3,000 feet a minute, you're thinking about harmonics now,
Yes.
right? Vibrations, harmonics, tensions are really important. So we're actually sneaking to the maintenance shop here because we've got a lot of the hearts on display here. And here's one kind of cut
wow.
open. So
yeah.
the faceplate of the machine's here, and just this little bit is sticking out.
Okay.
And we've got all the hoses and stuff hooked up to the front here to pull the vacuums. And one reason why we nickname it the heart, because we have an oil mist in here.
Okay.
And when it's running, it's got the nice red oil flowing through it like a heart would.
Those are just straight involute teeth, aren't they?
Yep.
That's interesting. So can I sit down in this chair?
Yes.
And
Oh,
kind of
yes.
engage with this?
This is really, really high precision stuff.
Okay, so I'm seeing, so you've got set screws here
Yes.
that are positioning each individual hole.
Yeah, so the lower sets there are called the dies, and up at the top is the punches, right? So we've got a punch and die operator.
Can I turn it?
Yes.
You think so?
Yes.
Okay, so I grab it here. Okay, that's a freewheeler. So I should be able to, yeah, look at that. Okay, so this is just one-to-one.
Yep.
I feel no mechanical interaction whatsoever.
Nope, yeah, so it's actually a through hole.
So basically, here's my knife. So this hole has to move left and right and up and down in order to index with the punch that corresponds with it. And do you know how many there are on the wheel?
96.
There's 96. And so those are paired.
Yep,
And they're tuned as a pair.
correct.
How long does it take to tune them?
Months.
Months to tune one heart?
Yep,
Are you serious?
yes.
Well, I have so many things I want to ask you. How is it driven? There's a big motor out this way. Right?
Yep. So got a servo on the
Direct drive?
direct drive.
Yeah, that's incredible. I'm noticing the slots on the inside. So you have a channel that has a vacuum in it.
Yep.
So you have maximized your vacuum surface area. Instead of having little holes, you actually distribute that vacuum over a whole lot of surface area. And that is a precisely machined part.
Incredibly.
So that's a monolithic piece, isn't it? That ring.
Every single die there is individual. And then
Every die is individual,
Yeah,
but
the vacuum chamber is all one big ring. That's right off the right on the drum.
yeah. So there's how many parts are just in this head?
Right. So you got the die drum, which is the thing that everything gets bolted to with the vacuum channels. And then you've got a set of die on each side, all 96 around.
And then you have the vacuum channel all the way around that.
Yeah, but that's right on the die drum itself.
Okay, and the surface finish of that is very important.
Incredible.
Because it's touching film.
Yep.
Okay, so where do the perforations go? After they get punched into the holes, which is the bottom piece here, how do they get extracted?
And you see this kind of ring light through.
Yeah.
It's bringing light through there. That's actually, we hook up vacuum right to the center hub here and pull out all the...
it comes this way?
Yep.
Okay, and that's that little hose that was on the front pulling it up and out. That's amazing. So do you ever have jams in here? Because if this thing's running super fast, what's going to happen is if it gets on one side and you get a clump of them, you get, centrifugal force? It'll sling it in there and you'll get the washing machine effect.
Yeah, or they won't want to come out, so you can't put more in the hole, and that's an issue.
Okay, and so then it gets imbalanced.
Yep.
So that's where the harmonics come in.
I'm struggling to express how impressive this is to me. Like, if you've ever designed anything, the idea of aligning all these posts to the dies and make this thing run at 3,000 feet per minute, it's incredible. Like, you have to make sure that you shear it, but you don't make contact. And there's hundreds of pieces in that assembly. This is very complicated.
Yeah.
So what is this?
So you'll be able to look through the microscope. You can't film through the microscope, so you'll actually be able to see up through the die looking up at a perf.
Okay.
When you look through here.
I look through the die.
Look through the die up at a punch.
Up at a punch.
So you got to be careful because this is an active one being worked on. So you can give it a little rocking back and forth too if you want.
Oh wow. So you're looking at the edges.
Yep. So that's how you're kind of going to use this tool to help set that up, right? Because you really want to be looking at that alignment of the punch to that die, right? Because having it touch is really, really bad at 3,000 feet a minute.
Okay, so you're looking at the back side of the punch.
Yeah, we're looking up through the die at the top of the punch.
Got it.
Where they're interacting.
So you're rocking that back and forth on this very important jig here. And you can throw this and slide it in and out as well, can't you?
Yeah, because
okay,
you want to
there.
look at the front perfs, back perfs.
Okay, so...
Front punches, back punches.
Oh, wow. So he's actually got, or she, whoever's doing this. Oh, wow. So there's some teeth that have been removed.
Yep.
Or punches, excuse me. Some punches have been removed. And so they're setting those. And everything's a special tool, isn't it?
Oh, yeah.
That's so cool. Everything's a special tool. That's amazing. Oh, and these are the fiber lights. I use these for Schlieren. Okay, just to see what's going on. So what's happening here is someone who's working on this is going through here. We've got the vacuum ring still there.
Yep.
And that's on the non-photo sensitive side, correct?
Correct. That is on the back side of the film.
The back side of the film. And so they're going through one at a time, these threaded holes. They are putting perf holes in? Is that what they're doing?
The dies.
The dies, excuse me. That's what a perf hole is called, a die.
Yep.
So they're putting those dies in one at a time, and they're aligning them. Man, I'm just now appreciating this part. This part has 96 sets of 4 threaded holes. So to kill that part is expensive. That part right there costs tens of thousands of dollars.
Oh, yeah.
That's amazing. These are all hearts.
These are all hearts.
Okay, and if one part on the heart, I'm estimating it tens and tens of thousands of dollars, and you have multiple parts, and then you have all of these little, I'm sure they're hardened steel posts. What did you call the post again?
Punches.
Punches and the
then
dies.
Carbide dies.
Carbide dies. Okay, so this room represents a lot of money.
Yes.
That's incredible. Okay, thank you very much. Okay, so we cut the film, we put holes in it, now we get to put it in this little can, which means we have to build the can, which is more complicated than I originally thought.
You get these large metal sheets in
Oh,
with
wow.
all the magazines printed on it.
And they've already got the metal code on there
Yep,
so that the camera can read the ISO of the film.
correct.
The man in charge of cutting these things up is Donovan. I'm Destin again.
How's you doing, Destin?
So, are you gonna show me how to cut these things?
Sure.
Is that cool?
That's great.
All right, let's go. Donovan showed me how they cut the big sheets down to strips, which will later become cans. Wow. That's fast. So you visually inspect every single, wow.
Yeah.
Every single strip gets looked at by a human. That's legit.
So now you flip it like this, and you look down.
Your brain is doing some neat stuff right there.
Well, the more you do it, the better you get at it. Anything silver, because it's a matte finish. It's a matte back. Your silver will reflect in the eyes.
Yeah. We then walked around the corner and Donovan showed me a machine that was making the little metal end cap for film canisters. So you're taking this metal at this point and you're turning it into that.
Right.
So this goes on the end of the can.
Yes, it does.
Wow. So do you remember those long strips that Donovan had prepared? Well, it's time to get those ready to turn into a can like this. And one thing you'll notice is right there on the edge, there's a little bit of velvet that makes that can light tight. The machine that normally does that was down for the day, but Patrick showed us how it would work if it were running.
So we're bringing the strips in that we just did on the metal slitter there, and we're hitting it with this big giant press, and we're doing all the crimp edges here, right, for your light locks.
Yep.
And then we're also cutting it out, right, because we got to stick the end caps on
How do you do that without knocking the paint off?
very carefully.
Good answer. Got it. So we're bending and
Yeah.
cutting at the same time.
Yep.
And
yep,
that's feeding along this way?
correct, right?
So we put a hopper in down there and it's taking them one at a time.
Yep. And then we start applying the velvet here.
Oh,
So
really?
This is actually happening upside down.
Okay.
So we're then we start putting the velvet on. So we're it's got an adhesive on the back. We're heating it and gluing it to the strips.
Okay. What does the velvet come in? Is it like a big roll?
Yep. So you'll see here.
This is the velvet?
Yeah. So we unwind it and we come through. We've got another accumulator here.
Oh, that's a velvet accumulator.
Yep.
Oh, that's cool. I like that. So it accumulates, and it doesn't have to have a pulley.
Correct.
Yeah, it
Yeah,
just
we're
kind
just
of
using
pushes it.
vacuum.
Yeah.
And then so we're gluing it onto the strip after it comes through here, goes through some heaters, and then we go through this knife set here, right? Because we don't want the velvet connected in between the strips because we got to cut it. So we actually cut the velvet separately.
It comes this way. Can I feel that?
Yep.
Oh, that is so strange.
And then now since the velvet's cut, we can use this press to where we're just cutting the metal. So we're actually got a couple of die sets there, and we're punching each of these strips separately, and then they'll be indexed in these trays.
Yep.
And that's one of those trays. We have some loaded ones over there.
Okay.
And then that's what we're going to use over at the dial to actually form this into something we can use at the spooler.
So we're going to turn this into a can.
Correct.
Down the hall, after these things were velveted, cut, and crimped, they're being loaded into one of my favorite machines on the planet. This is what actually makes the can. Let's watch it for a second, and then we'll try to figure out what's going on. Okay,
So metal comes out here, goes down, comes here, and it rolls it into a cylinder.
Yep.
It moves over here, it grabs a cap, and then as it moves forward, it puts the cap on, way back there,
Yep.
and then it crimps it on, and then towards the back, it stakes it. Is that right?
Yeah, so this is the staker here. So once it brings the cap over, now it's going to stake it, and then the rest of it's just conveyance, right? Picking it up, deciding if it's a reject or not, because we're measuring how well we actually stake it onto the magazine.
Got it. So good. It's so good, dude. It's so cool.
Okay, we've made the film and we've made the can. It's open on one side. We've only staked it on one side, but we have to put the film in the can and then we have to put it in this little container here. How do we do that? First of all, we get the other side of the can and we get it oriented correctly with a vibration rotation thing that gets it all aligned correctly. And then check this out, the little plastic canisters, they get them oriented correctly just by that little lip on the top, and they use gravity to drop it down. I could watch this for days. The lids for those cans move up this little conveyor belt, and there's these little sensors that tell if the lid is oriented in the correct way or not. If it's not, it kicks it out. Once all these components are oriented correctly, they then go through a light lock into the adjacent room where all of them come together in one complete package in a 35mm film can.
So you're Sermon?
Sermon.
Nice to meet you.
Meeting you too.
You run this machine?
Yes, I do.
Do you mind showing me how it works?
Okay. So this is the A cabinet.
Okay.
So we hang the roll. It seems like it's already
Is
there.
that a B cabinet? You have two?
Yes, we have two. We have A and B.
So you can have two rolls on there at a
Yeah,
time.
it's an auto splice.
Auto
It
splice.
slices-
Oh, I'm seeing these film caps. I recognize those.
Yeah.
Okay, so I'm seeing all the components.
Yes, they all come together here.
That's the magazine.
Got it. So you're running Kodak Gold today?
Yes. And the caps are coming right there.
So these are the lids?
No, those are the end caps.
The end caps.
End caps.
Oh, I see.
Yeah.
So
These are the lids.
can I show you the one from my pocket? Can you show me where the things are?
Okay. So these two. This one happens in the dial.
Okay.
And this one happens, it comes down here.
Okay, so
it happens here.
this end cap right here
Right,
is over here.
right,
And then the whole can is right here.
right.
And they come down here to meet.
Yes,
Okay?
okay. And then there's the cans right here.
All right, so there's the can.
Can,
And so we're going to end up with one in a can like this.
right. And then the lid is coming down there.
Got it. Oh, look at that. They're at right angles to each other.
Yeah.
So as it moves, it just kind of flops down.
Right.
Oh, that's neat.
Well, this is actually shining light through the belt and actually putting on that latent image you see for the frame markings and other information you have printed inside right there.
You can't see it on this,
Correct.
but when it's developed, so this is the thing that says frame number 1, 2,
Yep.
3. So this right here is the correct size for that.
Yep.
Interesting. How does it know where to start and stop? It's got to be reading the belt too.
Yeah, so we read the belt. We have positional marks on the belt so we know how many frames have gone by, how many we want to go by, and then we can quickly zip it back to the beginning when we're starting a new one. So this machine can run continuously while we're changing a roll. We can line it all up and it'll automatically splice when it finishes the other cabinet, and it just keeps switching back and forth so the spooler never actually stops, even though you got to stop to make the roll changes.
Gotcha. So when the film comes in here, then what?
Then it's coming up, and we've got this vacuum slack box here.
Right here. Can I go forward to the light
Yep.
screen? Go ahead, Sermon.
I'll show you.
So the film comes in, it goes up, down.
And that's a vacuum box, so there's actually the film in a loop. So obviously we're winding and stopping a whole bunch, which puts, you've got these big rolls with inertia. You can't really be starting and stopping those really quick.
Oh, okay, so those have to move at a constant rate.
Yep.
And then
You
you
said
are
as accumulator.
accumulator. And so this opens up.
This is the exposure. You could set it up for 36 or 24, whatever the exposure customer wants.
Right.
And it's also here too.
So you have an accumulator here.
Yeah, that's the big box to the left here.
Okay. That's an accumulator. This is the exposure setting.
Yep.
And this is also an exposure setting. Gotcha. And I'm seeing a perforation here.
Yeah, and that is right in front of you. That's the punch and die that's actually punching out that leader pattern.
So on the leader, on the film, right there, I'm seeing it like this.
Yeah.
So that's where it's cut, and then it goes there. And this is, can I look at that, Sermon? Yeah, sounds good. And so these are the leftovers. Okay. Gotcha. And so where does that go?
It goes up into the second exposure box. You got the nice web taps here.
That's amazing. Okay, so is this is a one roll of 36 and this is another roll of 36?
Yeah. Yep.
Gotcha. Okay.
And then we're coming to the threader, so this rotor here, this is doing all the business. It's an 8-station rotor that we're actually going to be doing all the combinations and indexing this around and putting all the parts together.
So Patrick then explains the machine to me, and it is so complicated, I think we would benefit from seeing it work first, and then we'll talk about what's happening. It all starts when a piece of tape is applied to a little plastic spool that's going to be the center of the film can. In the next position, the film is taped to the center spool and then it's rolled up quickly and then it's cut. The can that we made earlier is then slid over the top of the rolled up film. I know it's hard to see, but then a little end cap is put on, making the whole thing light tight. This little rocker arm drops a full can of film down in the little plastic case, and as the whole line advances, that causes one of these gray lids to pop on the top, and it's pushed down as it advances forward. So tell me where it goes.
All right, so we just put it in the can, and now we're going to shoot it in this tube, up and around with air.
Over here?
Yep, down through this tube, down around here.
So right here, it goes
up, over the spooler, and out into the white light where the packaging lines are.
Thank you very much. You're very welcome. I appreciate your time. So after the film can is put in that little plastic can, it all goes through a tube back into the next room, and I met a very special person that gave a fantastic description of the final packaging process.
My name's Rich Galena, and basically what we do here is package 35 millimeter as it exits the spooler through that tube.
Okay.
In which case then it comes around here to our 3P packaging line, and it's formally packaged in several different formats. We run singles, hang tab packages, we run 5-packs, 3-packs, 2-packs, several different options. In which case, after it comes out of the 3P, every different station on it, we have 12 in it, continuously running. They all do something different. After that, when it comes out on the table, the inspector here and packaging individual will check it for any damage. He'll check the carton print on it for expiration, and with that, we'll put the proper amount in the box right here with the label saying how many of those particular packages that we have in that case. The case then gets put through the taping machine. After that, it goes down and we stack it on a pallet.
So he's over there ready for it, right?
That's correct. Yeah. You'll see the cartons come in right here. We manually put them on. it feeds with the 3 suction cups that pulls the carton open.
Right here?
Yes, right here in this position, number 1. In this position, number 2, what we do is we have this little arm comes up. You can probably see it better from this angle.
Okay.
And what
Like right this?
Yeah, go, scoop right in. Okay, and that little bottom kicker arm will end up bending that flap
so
upward.
this thing right here is bending the tab over.
Right, the bottom flap only, and then this bar right here forms the other bar to be like this.
Oh, okay, so you were actively closing the left side, but the right side just gets hit by this rail.
It does. The rail takes it and does the completion part of it.
Gotcha.
At this point, what we're doing is we're loading. We're running 5-pack right now. So it'll load 5 spools right down into the carton.
Oh, okay, so this is our tube right here. Can I get where you're at?
That's the tube coming out of the spooler.
So this is the tube coming out of the spooler.
That's correct, sir.
Comes down to right here. And what do you call this this swing arm that I'm seeing that's doing this?
Actually, it's like a loader of some form.
Just a rotary actuator.
Right there?
Yep.
Oh, okay, so it's grabbing. Am I in a light screen? Is it beeping at me?
Nope.
Okay. Oh, I love the way this sounds.
Yeah.
And so it's dropping and counting.
Yep.
It is. 5. It's looking for 5. But the program within the machine logic loads 5 based on the input in that verse of you.
Gotcha.
We then come over here, excuse me, Patrick. We come over here, and these are metal detectors.
Ah.
Because the outside of our 35mm shell is metal, these metal detectors are looking for 5 in this particular unit.
So it's important that the can is ferrous so you can detect that.
Right. So, typically this is a very good check because we won't never miss. If it does have less than 5, the machine will stop and tell the individual to come to this station and remove it. In which case there could be 4 or 3, perhaps some sort of jam caused that. After that, we have basically this top kicker. It looks identical to the bottom kicker right there that bends the flap under. This one bends the flap down.
Okay.
Okay.
Can I look at it right here?
Oh, absolutely.
So
Focus in.
same situation. We're actively closing the left side, and the other
Right.
side hits the rail.
Right. The right side will, when it indexes, the rail will close it. And at the same time, it'll fast print the emulsion number on this particular carton and the expiration.
So you're saying the emulsion number is being printed on the side of the package right there.
Well, actually right here, if you get this better view right there.
You can see it.
There's your emulsion number and expiration date on top.
So is this being glued in position?
It will. At the very next station, okay, all your flaps will be tucked. At this point then, it'll be so fast, you'll get a shot of glue on the top tab and a shot of glue on the bottom tab.
It's happening top and bottom there, or where's it happening?
Right in front.
Oh, I see.
Here, it's right in this area here.
I
It's
see.
The flap are actually down there. Okay.
Oh, okay, I see the
and
flap.
As soon as it comes by, what will happen is it'll shoot just a little spritz of glue, top and bottom.
Gotcha.
Okay. At that point, these rails here will just compress it together for a short period of time.
Oh, okay, just mechanically
Right
constraining
here.
it.
Yes, right here at this station, sir.
So I can imagine you've got those rails set for a 5-box.
Exactly, right. And we have several 3P packaging lines, so they're all set up for different units or configurations, as we call it. Okay. After that's held here for a couple of seconds, it'll then come over here to where it's checked once again. It has lights on the top there to make sure that the flap isn't up in the upward position, because we don't want one of those to get by to the consumer. At that point, it's ejected with the suction cup, one high, one low. It grabs the unit carton, And you can see it slides right down the little chute. And our packaging operator then inspects it once again and puts it in the box.
So do the heavy ones slide farther?
Not really. It depends how the table is wrapped for.
Gotcha.
So they are really from
So you send that way, it gets taped, and then you unfold a box. Man, you get to see stuff roll off the line. That's pretty cool. So do you stay here all day, or do you rotate with?
we all rotate.
Everybody rotates? So what do you do here? I'll watch that cable for you.
All right, so here you just place the boxes on the pallet, and we always make sure the labels on the corners, the labels are always sticking out.
So how long have you been working here again?
4 months. December will be going on 5.
You like it?
Yes, I like it. It's something different. I work in a bunch of different packaging companies, so I'm used to, packing. So it's something different. Everyone here works together. It's a good team project.
Good team project?
Yes.
That's cool. You said you were the youngest guy here, huh?
Yes.
Are you hoping to work your way up?
Yeah, everyone keeps saying I'll be here the next 40 years. So we will see.
Yeah?
Yeah.
Nice to meet you.
Nice to meet you.
45 years.
45 years? You running away, man. So you got 45 years here? 40. Are they good years?
Yes, they're wonderful years.
You like working with everybody here?
I don't mind it.
Yeah? It seemed like you got some good folks. What are you working on right now?
This machine here.
Is it working?
It's down right now.
Is it? So you're trying to fix it?
Well, maintenance is trying to fix it.
Gotcha. Awesome. Nice. What's your name?
David.
Nice to meet you, David.
You too.
Awesome. I can tell that she picks on you, doesn't she?
She's known me a long time.
So y'all are like family.
Yes, we are.
Yeah, I would say we are. Yeah. I've known her a long time.
That's awesome.
Okay, so if you've stuck with me on this 3-hour tour of the Kodak plant in Rochester, New York, how did it make you feel? I'll tell you how it made me feel. I feel like these people are a family. Like, these people are making things together with their hands. It's the strength of American manufacturing. You've got the older generation teaching the younger generation, and the younger generation is rising to the challenge, and they're learning these really interesting techniques, and they're getting it done, and it makes me feel really, really good. So there's one obvious thing left to do, and I'm excited to share this with you. But as you watch this happen, just think about where we've been. We've made the backing, we put the light-sensitive coating on that backing, and we've seen how they slit it and package it. It's an incredible process. It's a marvel of engineering. So I want to say thank you to you for watching this, and thank you to everybody that supports Smarter Every Day on Patreon. It's a really big deal. Thank you for helping do this whole sort of thing, and thank you to everybody at Kodak at Rochester for letting this happen. So with that being said, let's go talk to Rich, and let's do what I think you are waiting for.
So Rich,
Yes.
there's something I want to do. I've got a camera with me. I want to get a roll of film off the line and take a picture immediately.
Okay.
Can I do that?
Absolutely.
Okay, so
You're winging it.
I'm winging it, man. All right, so we got a camera here,
Okay.
ready to do this. I'm excited about this, Rich. All right,
All right.
I'm ready.
First of all, you would take this off. This is a little bit irregular. I'm used to using a Kodak Cameo Easy Shoot. This one I see you have to direct the leader in and to set your ISO setting. In this case, you would set it to 400.
Yep, it's got the.
Oh, you do have a barcode reader.
Yeah.
Okay, I'm not used to the camera.
Oh yeah. Can I get a picture of you guys?
Absolutely,
Can I
yeah.
get a picture of you guys
We're
together?
a team. We're
You're a
all
team,
of us
ready?
are a team. Yeah.
All right, here you go. Ready? Get some muscles.
Oh, come on.
Come on, Big Rich.
I don't have
muscles,
any.
man. There we go. There we go. Thank you guys. That's awesome. You guys. That's awesome, man. Nice to meet you, Dwight, up top. That's awesome. That's great. I'm gonna get one of you guys too, right here. Right. 1, 2, 3. This is so good. It's fun. Rich, man. It's nice to meet you,
Justin,
dude.
it was nice to meet you.
Yeah.
I'm glad to help you out in your tour, and I hope you got some detailed explanation around the 35mm process.
Thank you so much, sir.
Alrighty.
I hope you enjoyed this. Please consider going and shooting some film. And I love making videos like this. If you want to support, you can do that at patreon.com/SmarterEveryday, or you can sign up for the email list at SmarterEveryday.com. That's a really good way to figure out when I upload a new video. Anyway, that's it. I'm grateful. I'm Destin. You're getting smarter every day. Have a good one. Bye.